Hello students, now we are going to discuss different types of distance time graph, distance time graph and displacement time graph. Okay. First I would like to discuss distance and displacement. Distance means total path covered, total path covered. Okay. And displacement means shortest path covered. Shortest means the only the distance between shortest distance between final position and initial position. Okay, let us discuss about the properties of distance and displacement. Distance may be positive, may be zero, but never negative. But displacement may be positive, may be negative, may be zero. For example, let us suppose an object is moving like that. This is the coordinate axis. An object is starting moving from this position, and it is moving here, then at last here. Okay, this is positive direction and this is negative direction. The distance is the total path covered. It is positive. Okay, but if we calculate displacement, the object is going in the negative direction. That means here displacement is negative. Distance is positive, displacement is negative. But in other case, for example, the object is going like that. Okay, the distance is positive and also displacement is positive because both are in the positive direction. Okay, and third example, that is the object is moving like that and then after reach to the same point from the starting point. That means the distance is the total path covered and displacement will be zero because final and initial position or point is the same point. Okay, means the shortest distance between final position and initial position will be same, means zero. Okay, means for in the displacement may be negative, may be zero, may be positive, but distance will be only zero or positive. Distance will never be negative. Now let us move toward the graphs, that is distance versus time and displacement versus time. First graph, that is distance versus time. Distance versus time means when the this graph shows that time is changing but the position or distance is not changing. The distance is always constant. That means the object in this graph, the object is stationary, means object is at rest. Now second graph that shows the straight line, and that graph is between distance and time, distance versus time graph. The line is straight, that means the velocity is constant, means at any particular interval time of interval, the change in time for every equal time interval, the change in the distance is equal, means every equal distance covered in equal time of interval will be the uniform speed. Because this is distance, that means there will be a uniform speed, means constant speed. The object is moving without changing its speed. Okay, here you will see that if you divide equal part of time, okay, now what you will see that in equal time of interval the change in position is not same. In equal time of intervals the change in position is not same, but change in position is increasing. first it is less, second time it is more, and third time it is more. Okay, means the change in position is continuously increasing. That means there is an acceleration, means well speed is increasing here. Third, same, if you take equal time of interval, what you will see that the change in position is decreasing. In equal time of interval, the change in position is decreasing. That means there is a retardation. Okay, now fifth, graph number 5. What you will see that time is not changing. Without change in the time, the speed have infinite value, means suddenly the speed becomes infinite. This is not possible. Okay, to become speed very high, there may be some time changement, but the graph shows that there is no time change. That means this graph is not possible. Okay, without changing its time, the velocity becomes infinite. This is practically not possible. Okay, that means this type of graph is not possible. Now graph number 5th, this is 6th, graph number 6th. That is what? That is the distance versus time. If you go from this position to this, let us suppose the graph is like that. The distance is decreasing. Distance will never decrease. Displacement may decrease. Okay, distance will always increase. Okay, here the graph shows that distance is decreasing, time is increasing, no problem. That means from this point to this point, according to the time, this is valid, and from this point is also according to the, means whole graph for the time only is valid, but for the distance it is not valid, because distance can never decrease, and also distance here that point distance is negative, which is not possible. That means this type of graph is not possible. Now let us move toward the last graph of distance time graph. Okay, now seventh graph that shows that here from this point to this point, distance is decreasing, also distance is decreasing, but here time from this point to this point is increasing, it is valid, but here time is decreasing. Time will never decrease. This is very, very important. Time will never decrease. That means this graph is also not possible. This graph of is not possible when the time is decreasing, because it is not possible that time will decrease. Now let us move toward the second point of this discussion, that is different types of displacement time graph. Different types of displacement time graph. First graph that shows displacement versus time. That means here displacement is constant, means displacement is not changing here like that. Distance is not changing. Here time is increasing, time is lapping, but displacement is not increasing, not decreasing, it is constant. That means here in this graph the object is at rest. Same here, object was at rest. Now same graph here, because the displacement is continuously increasing, gradually increasing, and increment is constant. That's why this is for constant velocity, this was for constant speed. This shows that the increasing velocity is increasing, change in the distance is increasing. That's why it is a positive acceleration, means speed is increasing. Here the speed is decreasing, that means there is a retardation like that. Okay, we will not discuss in detail because we have discussed here in detail. Now same graph here, this at without changing its time, the position is the position become infinite. It is not possible. Okay. Now this graph, time is increasing. The displacement is also decreasing. At here time is time have some value, but displacement is 0. It is possible. Here displacement is negative. It is also possible. Displacement is decreasing, possible. Displacement is 0, possible. Displacement is negative, it is possible. That means this graph is valid. Okay. Here, if this is graph, because if you have taken minus time, that means before 5 seconds, this is negative time, but it is possible. Why? We may have time before 5 seconds. This time shows that the object is started before we have started our stopwatch. Means we have started the stopwatch from this point, but the object is begin 5 minutes, 5 seconds, 5 hours before we start the counting the time. Okay. This graph is valid. Here time is negative. Time negative means it may be because when here at that point we have started counting our time, but the object is started before the starting our counting. Okay. It is possible. Time decreasing not possible. Time will never decrease. Time may be negative. Okay. I hope you are understanding. This is very easy, and this type of example is in NCERT. We will discuss NCERT examples and questions also. This is valid, but here the time is decreasing. It is not valid. Time may be negative, but time will never decrease. Hope you are understanding. This is very, very important. I suggest you to go through these graphs very carefully, because if you know these type of graphs, you will be able to solve, or you will be able to sketch the graph between two physical quantities, and it will help you in the 12th board examinations. Hope you are understanding, and thanks for watching.